So now that we've talked about a bit of our different types of cables, we've seen that we have a lot of different cables and a lot of different connectors. Not all cables and not all connectors transmit information in the same way. There are two major distinctions that are important to look at. One is going to be our analog versus digital transition, and there's another that is our parallel versus serial. Now, our analog and versus digital, we've already talked about a little bit. When we're talking about analog, when we look at our signals, they're going in waves like this. When we're talking about our digital, we're talking about signals that look like this. When we're converting an analog signal to a digital signal, it takes a little bit more than just connecting the wires to the different connectors. We can buy connectors for analog to analog devices or digital to digital devices that simply all they do is transpose pins and transpose connectors, and we can make those connections because it's the same type of data that's traveling over those connections. But when we're using transitions such as HDMI to VGA or DVI to VGA, we're going to have a little bit harder of a time. We may need larger connectors, or in the case of DVI to VGA, DVI I connectors also carry analog and additional to digital in the expectation that we may need to make that conversion. So it has those additional pins. But HDMI to VGA, we actually need a full box connector to make that different transition for us, to actually make that change from the digital connection to the analog connection. Our other type of distinction between cable signals is going to be our parallel versus our serial. When we're talking about our serial transmissions, these transmissions are going to be one bit at a time. So imagine a tube that represents our wire, and it's going to send these bits in packets. So we'll have our start bit, and then this will let the receiving end know that we're starting a bit of data, we're starting a packet of data, followed by our data. After our data, we're going to have our stop bit, followed by our parity bit. What essentially our parity bit does is it helps our end point to be able to check that data and just make sure that everything's going okay, make sure the data is correct. This is a very, very simplistic way to look at the packet of data that's being sent, but this is an illustration to help us understand how the serial data is being sent. So we can see that we aren't sending more than one bit at a time, and then when we're going from our CPU sending in, and our CPU is sending this data through a SATA cable, which is a serial ATA, over to our hard drive, which is on the other end of our serial ATA. It's going to send that data one bit at a time. When we're talking about our parallel transmissions, this is actually going to send our bits 8 at a time, at least. And they're going to be going simultaneously across the connectors. So we can think of it as all of these different lanes. We're just going to do these couple lanes here. And we have our CPU on this side, sending data over to our hard drive on this side. We'll give them a hard disk in there. And rather than sending the data as such, it'll send it like this. Rather than sending them one at a time like this is doing, or each of the bits are sequential, it's doing them more at a time. And it's pushing them across that parallel connection over to our hard drive. Now, when we think about it in theory, we look at this and we say, well, why are we moving from parallel, like we had in our IDE or our PATA cables and connectors? Why are we moving from that to serial? It looks like, parallel, it's a bigger lane highway. Serial, it's only one lane. You would think that we'd dramatically increase our speed if we just kept with the parallel. Well, parallel presents a couple different problems to us. First of all, and most obviously, it has more wires. When we're looking at a serial connector, we have a serial ATA connector, we have 7 pins. And it's a very small, thin connector. But when we're looking at an IDE connector or a PATA connector, we have 40 pins, and it's an 80 wire connector. It's a much bigger ribbon cable. It takes up a lot more space in our computer. And in addition to that, there's a lot more complex signaling circuitry and timing that has to go on between these two. With the parallel, we're having to send these at the same time, so the timing is going to have to be a lot more precise. There's a lot more room for error, and there's a lot more opportunity for, say, electromagnetic disruption, electromagnetic interference, EMI, will have a greater effect on this parallel cable because it's bigger and it's transmitting the data in a much more precise fashion. It needs much more exact timing. But with our serial, we just have our single connection going across. We're going 1 bit at a time. So our connection is a lot more stable. We're not getting as much interference. So we result in better connection and more reliable connection rather than parallel. So that's why we're moving away from parallel connections like IDE and PATA, and we're moving over to serial connections like SATA. High-speed serial connections, high-speed SATA connections are much more reliable and much better for us to use going into the future than our previous parallel connectors. So, thank you for joining us today here with Cybrary.it as we talked about some of our peripheral type connections and connectors. Hopefully you'll be able to join us next time. I'm Anthony, and we hope you enjoyed this video.